Record ni Azri.
Okey, jadi
Record.
sekarang buat dah record kan?
Dah.
Saya
Dia macam start lah Azri.
Dah, tak apa. Boleh.
Okay.
Azri boleh teruskan.
Start ya?
Azri tak payah buka ni, kau tak payah buka video.
Saya tutup video Baik. Jadi sekarang kita dah pukul 5 dan kita dah live di FB Aksara Cawangan Taiping. Jadi saya rasa eloklah kita mulakan majlis kita pertama. Baiklah. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh dan salam sejahtera. Bersama-sama dalam Taiping Lecture Series yang bertajuk SPM Chemistry Get to Know Corrosion. Okey, baiklah. Apa khabar semua? Alhamdulillah bertemu lagi kita pada hari ini pada masa yang sama dengan pengisian menarik yang seterusnya. Terima kasih kerana masih setia bersama-sama dengan kami secara langsung di platform Zoom dan di Facebook Live Aksara Cawangan Taiping. Kepada anda yang masih belum ikuti kami, jangan lupa untuk ikuti kami di Facebook Aksara Cawangan Taiping ACT, Instagram dan Twitter @Taiping serta channel YouTube Aksara Taiping untuk info perkembangan terkini Aksara Taiping. Baiklah rakan-rakan penonton, eloklah sekiranya kita bersama-sama membuka dahulu majlis kita petang ini dengan bacaan Ummul Kitab Al-Fatihah. Amin amin ya rabbal alamin. Baiklah, sebelum memulakan majlis, ingin saya ucapkan ucapan ribuan terima kasih kepada rakan-rakan strategi Aksara Taiping, iaitu Jabatan Kimia Mata Rendah Sains Smart Taiping serta TNF Energy Sdn Bhd. Sebelum saya memperkenalkan speaker, saya eloklah sekiranya saya memperkenalkan diri saya. Saya ialah Muhammad Azri Akmal Hazim bin Muhammad Azri, Aksara Taiping daripada batch 2020. Kini saya menyambung pelajaran saya dalam asasi kejuruteraan dan sains komputer di Universiti Islam Antarabangsa Malaysia, dan saya ialah asisten untuk Biro untuk Exco Komunikasi Aksara Taiping bagi tahun 2021-2023. Baiklah, pada hari ini kita sangat beruntung kerana bersama-sama dengan kita ialah TS Nurul Izni Khairi daripada batch 5, iaitu lecturer di Universiti Teknologi Petronas, serta Miss Nurdian Muhammad Rizwan iaitu part-time lecturer dan PhD candidate serta di Universiti Teknologi Petronas. Apa khabar Puan Nurul dan juga Miss Nurdian?
Say hi.
Sekejap ya. Berhilang.
Alhamdulillah, terima kasih kerana sudi meluangkan masa bersama-sama dengan kami pada petang ini. Baiklah, tanpa melengahkan masa lagi, saya menjemput dan mempersilakan TS Nurul Izni Khairi dan juga Miss Nurdian Muhammad Rizwan daripada Universiti Teknologi Petronas untuk menyampaikan perkongsian mereka, iaitu SPM Chemistry Get to Know Corrosion. Dipersilakan.
Okay, thank you so much Azri. Thank you so much Cikgu Julia, Cikgu Aisyah for having us today. So a little bit of introduction about me. So actually you can call me Madam Izni or maybe Kak Izni also can. So I used to be your super senior back in 2004 and 2005. So it was 15-16 years ago since I left MRSM Taiping. So together with me today, I have Miss Dian. So my colleague from Center for Foundation Studies in Universiti Teknologi Petronas. So here we are today. We are supposed to deliver some sort like I consider as lecture. So to our dearest students in Taiping right now. So we are going to talk about corrosion. So but before that, kita nak sembang-sembang corrosion ni, it's a little bit hard for me to directly jump to the experimental part. So what we are going to have is that we are going to go through and explore a little bit on corrosion. Okay, nervous ni sebabnya yang tengok kita lah cikgu kita sendiri kan. So we just try our best, okay? So just that one thing for sure lah, we are not an expert in corrosion. We are not coming from corrosion punya industry or whatever. Just that we are sharing our knowledge to you so that you can explore and see the beautiful part of chemistry. Now focusing on the application part of corrosion. Okay. So now this one would be our presentation flow. I think that I'm going to deliver in English, okay, because I used to deliver in English. If you have question, so just feel free to interrupt us, either me or Miss Dian. So we are going to answer your questions straight away. Okay, so this would be our presentation flow for today. So we are going to talk about theoretical part. We are going to explore on redox reaction. We are going to explore on galvanic cell and corrosion as well as rusting. So when it comes to corrosion and rusting, I think quite a number of students still confused what is the main difference between corrosion and rusting. But truth to be told is that you know that when it comes to corrosion, you are talking about redox reaction. So it's basically back to electrochemistry. Okay, now we are going to look into discussion on the experimental part. So I have been made to understand by Cikgu Julia, my teacher, that you guys has been assigned to go through a simple experiment that you can just find anything from your household item. So you just need to demonstrate on the application of corrosion. Okay, or maybe basically you're going to look into the rusting part. Okay, now we are going to explore on that part as well. And then I will pass the session to Ms. Dian for application of corrosion knowledge and how to slow down the corrosion process. And truth to be told is that it's going to be a little bit hard for us to stop corrosion because it's happening. So the only thing we can do is that we can just slow down the process. Okay, we cannot stop it completely, but we can just slow down the process. And then we're going to have some sort like activities, a gameplay time. So just make sure that you guys are attentive. So we're going to award maybe 2 or 3 students who actively participate in the session together with us today. Okay, so take note on the points that we are going to deliver. So the questions that we are going to ask you might come to any of the points that we deliver. And last but not least, we're going to summarize everything. So based on the flow of presentation that we have today. So now move to learning outcomes. So sebab lecturer dah biasa ajar kena ada point kan. So basically the learning outcomes that we put over here is basically based on what we are going to present. Okay. So now redox. Theory on redox, galvanic cell, corrosion, and rusting. I think you guys have been introduced to this part. We are talking about electrochemistry. So when it comes to electrochemistry, we are basically studying on the chemical reaction and also electricity. So you know that how you generate electricity is basically coming from the movement of electron. So when it comes to electrochemistry as well, you guys have been introduced to galvanic cell as well as electrolytic cell. So to be honest, both galvanic cell and electrolytic cell are basically simple form of electrochemistry knowledge. The only difference is that for galvanic cell, it is basically a spontaneous process. Okay, so a spontaneous process, whereas when it comes to electrolytic cell, it is basically non-spontaneous process. So what is the difference between spontaneous and non-spontaneous process? So for a spontaneous process, when you have your chemical reaction, it will produce electricity. But for non-spontaneous process, in electrolytic cell, you need to drive it. How you drive it? For example, you put battery. So when you put battery, electricity is going to be generated to produce some sort like chemical reaction over there. So it's the reverse process. So you force it to happen. So automatically it's going to be a little bit different compared to what you have under galvanic cell. And then when it comes to electrochemistry, one thing for sure you must know and able to relate about redox reaction. So redox is basically reduction and oxidation. So meaning to say, under electrochemistry, be it whether you talk about galvanic cell or electrolytic cell, we will talk about reduction and oxidation that happens simultaneously in a single time. So you are talking about electron transfer. So in oxidation process, electron is going to be loose, and the electron that you lose in your oxidation half cell equation is going to be gained in your reduction half cell equation. So that will determine the position of the electron in your chemical equation. Okay, so this is, I think, quite common to you. We use this term LEOGER. So that is basically the indication on the correct position of your electron. So just pick up this example. So imagine that you have zinc, solid state, plus 2H plus ion, aqueous state, and producing zinc 2 plus aqueous state as well as hydrogen gas. So when you look at this part, now if I ask you, how do you determine which one is basically going to be oxidized and reduced? The first thing that you can look at is that based on the oxidation number. Okay, so you can see over here, so you have zinc metal. So when you have zinc metal, the oxidation number of zinc metal over here is 0. Why the oxidation number is 0? Because this is 3 element. Okay, now from zinc, you produce zinc 2 plus, so the oxidation number changes from 0 to positive 2. So when you are comparing, it must be apple to apple comparison. So your comparison basis is coming from zinc metal, producing zinc 2 plus, and you know straight away that you increase in the oxidation number. Okay, so let's say I just put the equation over here. So zinc solid producing zinc 2 plus aqueous. Okay, and then one more equation is that what you have over here is that you have 2H plus aqueous, and then you produce H2 gas. So you can see over here, the oxidation number is basically positive 1 times 2, and then here is 0. So you know that for zinc, you have an increase in the oxidation number. So when you have an increase in the oxidation number, so it will indicate oxidation process. So this is your oxidation half cell equation. So when you talk about oxidation, is where you are going to lose electron. So you can try to put over here. So this is going to be 2 electron located over here. Why 2 electron? You can counter check. Oxidation number here is basically 0, and here is positive 2. Now when you put plus 2, 1 electron carry negative charge is going to be 0. So it's a balance equation. So when it comes to ionic equation, you must balance the atom first. So since it's balanced side by side, you have zinc 1 mole in your left hand side, and another side you have zinc 1 mole. But the only thing that is not balanced is the charge. So you have to balance the charge by putting an electron. So when you put 2 electrons over there, so this is going to be a balanced half cell to indicate oxidation process. So since this one resemble oxidation process, automatically this one would be reduction half cell equation. So you see over here, you have 2H plus, so it's basically positive 2, and you need to put 2 electron over here. So plus 2 times negative 1, then you will get 0. So it's actually a balanced equation. Okay, now you have your oxidation half cell equation, you have your reduction half cell equation. Now you want to determine or produce or deduce your final net ionic equation. So we are talking about net ionic equation. So in your net ionic equation, electron term should disappear. So over here in your half cell oxidation side, you have 2 electrons, so you can cancel it off. So the same number of electrons, so you don't need to manipulate anything. So it will come out, your final equation is going to be zinc solid, so plus 2H plus aqueous producing zinc 2 plus aqueous plus H2. So you see it's the same equation that we have over here. So that is your net ionic equation. So you see from identifying the oxidation number, also the location of electron. So you see for oxidation here, based on this definition, LEO, oxidation is where you lose your electron. So electron is going to be positioned in your product side. The same goes to the other half cell equation, which resemble the reduction one. So it's basically positioned in your reactant side. So that's how you produce your balance equation. So in electrochemistry, it's very important for you to know how to balance equation. And the equation that we are referring to is basically net ionic equation over here. So net is basically a balance equation. Okay, so point number 1, what you have to do is that you have to make sure you check the oxidation number to indicate your oxidation half cell and reduction half cell equation. Second point, you can also use your position of electron. Okay, now moving to this part. So this is a basis comparison for oxidation and reduction process. So you must know the difference. So when it comes to oxidation, you're talking about loss of electron. So when you talk about loss of electron, you relate with Leo. Second one, when it comes to reduction, you talk about gain of electrons. So you talk about GER. Okay, so you talk about the position of the electron. So you must know the difference. Second one, another way how you can identify the half cell equation is based on the oxidation number. So should you have an increase in the oxidation number, it will indicate oxidation process. Should you have a decrease in oxidation number, you have to know that it's basically referring to reduction process. So oxidation number, of course, rule you have to follow. Either you are referring to ionic atau cation and ion, you have to follow whether you are referring to a free element. Okay, so that will determine the oxidation number. Okay, so and one more thing, when it comes to oxidation process, you are basically referring to reductant. And when it comes to reduction process, you are referring to oxidant. I think this one you're quite familiar because you have been introduced to this point. It is that I need to highlight it again so that you get a better or clear picture when I deliver about experimental part and so on. And of course, oxidation at all time, it's basically referring to anode side. And reduction, it is referring to cathode side. However, when you are comparing between galvanic cell or electrolytic cell, the charge of the terminal of your electrode is going to be different. So the charge of the electrode that you have in your cell is basically defined by the flow of current. So it's basically referring to the movement of electrical charge. So that's why sometimes when you are referring to galvanic cell, your anode is basically negatively charged. But for the other half cell, is going to be the opposite one. That is basically referring to the charge of your terminal that you have. Okay, now moving to this one. So this is basic setup for galvanic cell as well as electrolytic cell. So the main difference over here that you have to know is that this one. So in galvanic cell, you will have salt bridge. Very important, you need salt bridge. So you can just use any electrolyte. When it comes to electrolyte, it's basically referring to tendency that the electrolyte can be dissociated into its component ions. So for example, common electrolyte that we use is NaCl. So it is going to be dissociated completely since they are strong electrolyte to Na plus ion as well as Cl minus ion. Okay, so now you know you have your anode, you have your cathode. So in galvanic cell, your anode is negative charge and your cathode is basically positive charge. And you connect it to voltmeter. Why you connect it to voltmeter? Because this one is needed, a device to measure potential difference between your anode as well as your cathode. Okay, so the process that you are referring to here is basically you are talking about conversion of chemical energy into electrical energy, how you produce your current, and it can be measured to the reading that you get from your voltmeter. Okay, on the other hand, when you compare and look into electrolytic cell, since electrolysis is basically non-spontaneous reaction, okay, you have to drive the process by using battery. Okay, so the charge that you have in your anode side and cathode side, this is your anode, this is your cathode, is the opposite from what you have in your galvanic cell. So in electrolytic cell, what do you have? Your anode is positive charge. Why? Because it is connected to the battery, positive terminal of your battery. This is your negative terminal. I'm not going to discuss in detail about electrolytic cell because it's quite detailed. You need to know a few factors. For example, how you decide the products of electrolysis. You can have various medium to indicate your electrolysis and so on. But just good for you to know for this part that electrolytic cell is using non-spontaneous reaction. Why? Because you are basically referring to conversion from electrical energy. Now, in this case, referring to your battery so that you can generate chemical reaction. And you see, the terminal that you have over here is positive. So your ion here, your free moving ion is going to be attracted towards your terminal, the charge of your terminal. So for anode, since the charge of your terminal is positive, so it will attract all of N ions towards it. Same goes to the other side, which is your cathode. Since this is negative terminal, so it will attract all positive ion towards it. Okay, so now moving to this part. So it is actually referring to a similar equation that I use over here. So zinc solid plus 2H plus producing zinc 2 plus H2. So you see now you imagine you have zinc metal as your strip. Okay, so this is solid. So you just put your zinc metal and you embed it inside Cu2 plus solution. Okay, so since this is Cu2 plus solution, the color is blue. So you just have one electrode, you dip it in a solution, it's copper ion solution. You can just use copper nitrate. So in this case, I just put and want to indicate that this is your copper solution. And after some times, you would see that the observation that you can get, you will see that on top of your zinc surface here, when you take it out from your solution, you see this kind of color. Okay, why is that happening? So it's actually based on redox reaction. So zinc is basically going to be oxidized to form zinc 2 plus ion. So it's the same equation that we have over here. Zinc is oxidized to form zinc 2 plus ion. And then what do you have over here? The copper 2 plus ion here is going to accept electron that is basically loose from your zinc, and it is going to be forming some sort like copper deposit. So this is your copper deposit solid. So you see that is basically redox reaction. So zinc is being oxidized, so you produce a zinc 2 plus ion, and then the electron that you lose from the oxidation of zinc is going to be gained by a copper 2 plus solution, and you're going to produce copper solid. So you can try to generate the half cell equation for this. Okay, now moving to another more complex reaction. Now in this case, this is using the setup that we have over here. So you are using 2 electrode system. So when you're using 2 electrode system, over here you would see this is your zinc metal as the first electrode that you have. Second one is your copper electrode. So you see there is a reading that you can see from your voltmeter over here. So it's 1.103 volt. So it's basically the potential difference as a result of when you put zinc metal into a zinc 2 plus solution, as well as copper metal into copper solution, copper 2 plus solution. So what is happening inside here when you compare with the first experiment here, you just have first one electrode, second you have 2 electrodes. So now in this case, you would see that zinc here is the same reaction. Zinc is basically being oxidized to form zinc 2 plus ion. So you can try to create your equation over here. Okay, so you see, you release zinc 2 plus ion, and then you are going to produce 2 electrons. That's why electron is going to be migrated from your anode towards your cathode. Now you are yet to know which one is your anode, which one is your cathode. But truth is, you know that anode is where oxidation process occurs, and cathode is where reduction process occurs. Okay, so you talk about the oxidation number. So you see in zinc here, you have an increase in the oxidation number, and electron is positioned in your product side. So that's why it resembles the oxidation half cell equation. Actually, you have basis. How you identify that zinc is supposed to be your anode? You are referring to standard reduction potential. Okay, but then later we're going to jump into that part. So you see now you're releasing 2 plus, so the electron that you lose here is going to be migrated from anode towards cathode through external circuit. So this is the wire that you connect from your anode side towards your cathode side. And then what happened over here, you see, this is copper sulfate. So inside our solution, because this is aqueous, so it is going to be dissociated into its component ion. So you're going to have Cu2 plus as well as SO4 2 minus ion. So it's that free moving ion inside the solution. So what happened is that since you have Cu2 plus ion, so Cu2 plus ion is going to accept electron that you lose from your anode side, and you are going to produce copper solid. Okay, so it is going to be deposited on top of your copper electrode over here. So what happened over here, when you try to balance the equation, you just cancel off the electron terms. So you are going to produce your net ionic equation, zinc solid plus copper 2 plus aqueous, producing zinc 2 plus ion plus Cu solid. So the observation that you can see from this experiment is basically in your anode side, you would see that since zinc is being oxidized to form zinc 2 plus ion, the concentration of your zinc 2 plus ion is going to be increased. Okay, and then at the same time, if you measure in terms of you weigh your electrode, you would see that since zinc is being oxidized to form zinc 2 plus ion, the mass of zinc is going to be decreased at the end of the experiment. So that is the observation that you can see. Okay, and one more thing, on the other side of your cathode side, what you will see over here is that since Cu2 plus solution here accept electron and it is going to be reduced to copper solid, so you will see the mass of your copper solid at the end of the experiment is going to be increased, and that intensity of your copper 2 plus solution is going to be decreased, the color. Okay, the color of the copper 2 plus solution is going to be decreased. So that is some sort like observation that you can pick up from this experiment. So not to forget, in your galvanic cell, you also have salt bridge. So it is very important that you must install salt bridge. So without salt bridge, you cannot allow the migration of electron from your anode side towards your cathode side. So like what I mentioned just now, you must have any types of electrolyte. So when it comes to electrolyte, you will have components ions. So over here in your salt bridge, you just have Na2SO4 in aqueous. So you will have your Na plus ion and you will have your SO4 2 minus ion. So theoretically, we have reason why anions is going to be migrated towards your anode side and cation is going to be migrated towards your cathode side. The reason being because as you can see, as the zinc is being oxidized to form zinc 2 plus ion, the concentration of zinc 2 plus ion is going to be increases. So when the concentration of zinc 2 plus ion is too high, you need counter ion to balance it. So the counter ion is coming from your salt bridge. So that's why when SO4 2 minus ion migrated towards your solution over here, you can decrease back the concentration of zinc 2 plus ion. And because of that, you can allow electron to be migrated from your anode towards your cathode side. And on the other hand, the reason being why you are going to allow cations coming from your salt bridge to be migrated towards your cathode side, because over here you will see Cu2 plus solution is going to be decreases. Why over here concentration of Cu2 plus is going to be decreases? Because Cu2 plus in your reduction half cell equation, it is going to be reduced to form copper solid. So the concentration of Cu2 plus decreases automatically. SO4 2 minus ion increases. So you need counter ion to increase back the concentration of cation over here. So that's why you need cations coming from your salt bridge to be migrated towards your cathode side. So that is the theory behind this galvanic cell reaction. Okay. So this is common table. So I picked this one coming from your textbook. So basically you will see this is stated to be as E0, so it's standard reduction. But the standard reduction that we are referring to, you can see the position of the electron here are all positioned in your reactant side. So this is basically E0 reduction. So we also have E0 oxidation, but since this table is using E0 reduction, so you will see from galvanic cell reaction, theoretically, you know that reaction is supposed to be spontaneous. So when it comes to spontaneous reaction, the formula that we are referring to is that E0 cell, which is your standard cell potential measured in your voltmeter over here, is equal to E0 reduction cathode minus E0 reduction anode. So that is the formula that we are referring to. And since we are referring to galvanic cell, the E0 cell value must be positive. So meaning to say we must have a bigger value or more positive value for E0 reduction minus with less positive value for us to be able to get positive value so that we can build up our galvanic cell. So theoretically, when you look at this table, for example, when you are comparing between two reactions, for you to be able to tell out which one is supposed to be a reduction half cell and oxidation half cell equation, it's referring to E0 reduction. So in the example that we have here, you can check the standard reduction potential for zinc 2 plus ion producing zinc solid, as well as in comparison to Cu2 plus. You would see that the E0 reduction for Cu2 plus is supposed to be more positive. So I just pick up this one. So this is Cu2 plus, the E0 reduction. And then another one is basically zinc 2 plus. So you see, since this is more positive, so that's why this is going to be your reduction half cell equation. And this is going to be less positive, so this is going to be reduction. Salah, oxidation, sorry. This is reduction. Okay, so that's how you're able to tell which is supposed to be your anode side, your cathode side, but theoretically at all time anode is where oxidation process occur. So this is the same table coming from what you have in your textbook. So you will see when it comes to oxidation, you need to reverse the equation. Reason being because oxidation is where you are losing electron, but all of the equations that we have here, the position of the electron is basically on your reactant side, which resemble reduction equation. Okay, but if you want to pick up based on this formula, so when you want to calculate and make sure that you will get positive E0 cell, you are going to pick up E0 reduction for your cathode. In this case, it's basically E0 reduction for Cu2 plus producing Cu minus with E0 reduction of zinc 2 plus producing zinc. So that is how you will get the value. Like you just plug in the value. So you will get positive value. So that is one of the way how you can identify which one should be your oxidation half cell and reduction half cell equation. So that is for you to get the idea. So it's basically the same table that what you have coming from your textbook here. So, and automatically you will be able to tell based on the strength of oxidizing agent and reducing agent. So most positive value. So this part is going to be undergoing reduction and less negative is going to be undergoing oxidation. Remember, when it comes to oxidation, you have to reverse the equation. Then only you will get your oxidation half cell equation. Okay. Now that is the theory on that redox part. So moving to corrosion versus rusting. So when it comes to corrosion, one thing for sure, you don't get it confused because rusting, it is referring to iron. Okay, so how rusting is possible is basically oxidation of iron in the presence of moisture and air. So in the presence of moisture and air, you will cause rusting. So rusting is iron trihydroxide. Okay, and then when it comes to corrosion, it can be any materials, any metals, any non-metals. And the result of it is going to cause them to be oxidized and it is going to be deteriorating the condition of your materials. But the end effect is the same lah. You're going to destroy the material. But for corrosion, it can be any material. But for rusting, it is specifically for iron alone. Okay, so if you look at this part, for you to have corrosion, it can be polymer, it can be ceramic, it can be non-metal. So, but you would see that the appearance sometimes it would be not as nice as when you first bought the thing. But when you compare with iron, it can affect all sort of alloys, all sort of iron. So what is the difference between iron and alloy? So iron is a metal. So you know in periodic table, you have group 1, you have group 2, you also have transition element. So if you have transition elements, so they are coming from group B, it's in your periodic table, it's B, coming from B. So transition element is also metal. So for transition element, you can have more than one oxidation number. But for group 1 alkali metal, the oxidation number is +1 at all time. For group 2, your main element, the oxidation number is going to be +2. The only difference over here, if you have or referring to transition element, the oxidation number can be more than 1. So when it comes to metal, you know that metal have higher tendency to be oxidized. Okay, so that's how you produce your cation over there. So, however, for rusting, when you want to compare iron, so this is metal alone, and alloy, it can be iron as the main element, and you will have some sort like additive. Okay, so alloy, for example, you combine iron with carbon, you combine iron with chromium, you combine iron with molybdenum or anything. The reason why you will produce your alloy, because sometimes based on the application, you want to improve the properties, you want to increase the corrosion resistant, you want to make it more shining and so on. So that's why you need to change the properties a little bit. How you change it? By having iron as the main component and you add up a little more component other than iron to improve the properties. So for rusting, it will affect any iron or any alloy. So if you have come across to steel, you have come across to stainless steel, so they are basically having composition of iron as the main composition. Okay, now for corrosion, it will cause surface exposure to air or chemicals. So in the event that it is being exposed to air, it is being exposed to chemicals, so it will cause things to be corroded. However, for rusting, when it is exposed to air or moisture, you will see some sort like orange brown color. So that is the products of rusting. We call that one as iron trihydroxide. Okay, so this one, it will have different colors lah, but commonly it is seen as blue, green color. So that is the indicator to indicate that corrosion has happened to that particular material. Okay, so I hope you can differentiate between corrosion and rusting. Okay, now this is rusting of iron. The reason why you learn about rusting of iron, because iron is ataupun most abundant element that is being used. Okay, when it comes to the materials that you build up, your building and so on. So we use iron and its alloy, so that is main composition. So that's why you have to learn about rusting of iron. So you see, just now I mentioned, you must have oxygen, you must have iron, you must have water, and the result will be rust. You are going to form this one. So this is rust. Okay, I think you already learned about this one. So what happened over here, it's basically a form of redox reaction. So it's a spontaneous process. So why this is a spontaneous process? Iron is going to be oxidized. So this is the equation. I'm not going to repeat. Iron is going to be oxidized to form iron 2+. And what happened over here, the other side is going to be reduced. Your oxygen side is going to be reduced to form hydroxide ion. Okay, so this is, imagine you have your surface of metal. This is your anode side. Your anode is negative terminal, so it resembles your galvanic cell just now. So anode is negatively charged. So you produce electrons. So electron is negative charge. So that's why this is the anode side. So imagine this is a water droplet on top of your metal surface. In this case, we are referring to ion. So this is where you have your oxygen, but the composition of oxygen is a little bit lower compared to what you have at the center of this part. Kita panggil apa ya? Some sort like water droplet. Okay, and then you would see that you can balance the equation. Okay, and then you see your balanced redox reaction over here, your iron 2+, and it is accepting hydroxide ion. It is going to be producing iron 2 hydroxide. So that's how you produce this one. And further oxidation process of iron hydroxide in the presence of moisture, you are going to produce iron 3 hydroxide here. So that is your rust. Okay, this one you already learned. I'm not going to explain in detail. It's the same mechanism. Okay, so you must know it's basically form of redox reaction. Why? Because in the presence of oxygen, in the presence of moisture, and of course you're referring to iron as the main element, what happened is that you are going to cause the rust to be formed on the surface of your iron metal. Okay, now moving to this part, discussion experiment. So I can see that quite a number of submission received. So this is a very simple experiment to indicate the process. So you see, what do you have over here? You just put or have 3 different tube A, tube B, tube C. But for tube A, you will see over here, you have nil. Okay, and this nil is being exposed to air and water. So this one serves as a control experiment. So when you run any experiment, you must have your control experiment, right? So you know theoretically in the presence of air, in the presence of water, iron is going to be corroded. You're going to form iron trihydroxide, which is your rust. So that is theory. So that is the reason why tube A is going to be your control experiment. Okay, and this one is where you manipulate it, okay, for B and C. So you see, for B, you put oil on the surface of your water. Okay, and this one, you have your boiled water. So meaning to say, when you have your boiled water, you already lose some sort like air, trapped air inside it, because it is escaped to the environment. So, and then on top of that, you also put oil. So meaning to say, for tube B, there is no presence of air. Okay, for this one, so you lose one properties that will contribute to the formation of iron trihydroxide that is needed. So there is no air over here present. Reason, because you have your boiled water. So when you boil water, so this is liquid water. So of course, when you boil it, liquid water is going to be evaporated. You are going to form gas over here. So automatically there is no dissolved air, dissolved oxygen, you lose it. That's why there is no oxygen over here. So this is the first parameter that you manipulate. Second one, in cube C, you have anhydrous calcium chloride and you also put dry air. Okay, so anhydrous calcium chloride is functioned to absorb moisture. So you already absorb moisture, there is no water here. Okay, and second one, you have dry air, so automatically there is no oxygen. So then this is the experiment to prove that in order for you to produce rust, you need air and water. So that is the control environment that you have. So automatically, after some times when you leave it, this test tube, maybe for 5 days, 7 days, you will start to see some sort of appearance of rust on top of the nail surface. And of course, bila you nak buat experiment, you have to ask yourself, what is the material? Is it iron? Okay, or basically, is it carbon that you are referring to? Carbon is non-metal. Okay, or you use any other metal. If you are referring to rusting, you must make sure that the material that you use is basically iron or steel. Okay, wow, 542. Okay, so that is basically the experiment to prove. So at the end of the process, at the end of the experiment, you would see that in cube A, you would see some sort of appearance of rust. Why? Because this nail is being exposed to water, is also being exposed to oxygen, air. So that's why you will have rust. However, for cube B and cube C, since there is no oxygen, there is no water, so you lose the components needed for you to produce rust. So you would see that there is no rusting on the top of the nail surface. So that is the observation that you can see. So that is the experiment that you can try also. Now moving to another experiment. So you know that in order for you to promote a redox reaction, you need electrolyte. So when you have electrolyte, you will have some sort like, you will introduce electrical conductivity. So you will allow current to move. Okay, so you know when you learn about electrolyte, you have various types of electrolyte. You have strong electrolyte, you have weak electrolyte. So let's say when you do your experiment, you put your nail or basically any iron or its alloy, you put it inside acid, you put it inside salt solution. So they are considered to be a strong electrolyte. So kalau you ingat balik, when you have strong electrolyte, it is going to be completely dissociated into its component ion. For example, this is salt, common table salt. So inside solution, it is aqueous. So you are going to produce Na plus ion, aqueous plus Cl minus ion. If you have HCl, this is strong acid. So it is a strong electrolyte as well. So what happened is that when you have HCl inside solution, it is going to be dissociated completely to H plus ion as well as Cl minus ion. However, if you have acetic acid, cuka, CH3COOH, so aqueous. So this is weak electrolyte, so the arrow is not right. So when you have weak electrolyte, it is going to be partially dissociated into its component ion. So you are going to produce CH3COO minus aqueous plus H plus ion aqueous. But because this is weak electrolyte, weak acid, which is also known to be as weak electrolyte. So if let's say you have your solution, you put it inside a beaker here, you will have CH3COOH, you will have CH3COO minus ion, you will also have H plus ion. Okay, so meaning to say, because this is weak electrolyte, the components, some of the components remain intact as CH3COOH. Unlike if you have HCl, you put it inside a beaker, you are going to have H plus ion, you're going to have Cl minus ion, so it is completely dissociated. So when you have strong electrolyte, for example, strong acid, strong base, garam, and so on, so when you put your nail or whatever, when you put your iron material, so it will promote corrosion. Corrosion will happen more faster because this is strong electrolyte. When you have strong electrolyte, it can increase the conductivity of your solution. It will allow electron to move. So that is the reason when you put your steel material inside salt, inside acid, you can see that you enforce the formation of rust. Okay, but if you compare with this one, I just go through this part. So you see, you have dry air, you put your nail, so you put stopcock, so no moisture coming, no, because this is a closed system, no moisture coming in, as well as no water. Okay, what happened is that you will see there is no rusting at the end of the experiment. So another beaker that you have over here, you don't put any stopcock, so you just put nail and then you dip it inside boiled water and all. So it's the same experiment that we have over here. So the first experiment is for us to prove that air and water is needed to produce or to promote corrosion. Second one is more or less same experiment. Like what you did is just that you choose different electrolyte. So in the second beaker over here, you put boiled water and air. So basically no moisture coming in because you encap it, you put a surface that will not allow oxygen or moisture to come in, and you already lose your oxygen or dissolve oxygen inside your water because you already boil it. Okay, so that's why in the second beaker, there is no rust can be seen on top of the nail surface. And in the third beaker over here, not beaker, apa nama ni? What do we call this one? Test tube, I think. Okay, so you have water, just a normal water. Yes, of course, you will have rust. And of course, this is not, you did not put any stopcock, so oxygen is coming in. So when oxygen is coming in, you also have water. Of course, you will cause the nail to be corroded. And last one, this is strong electrolyte, is salty water. Okay, you increase the electrical conductivity of the solution because you're going to produce free moving ions over here. So when you have free moving ions, of course, automatically you are going to form rust on top of your nail surface. In this case, they are referring to rusting. Your nail, your material to build up your nail is basically iron. So it's similar experiment. So this is what you can think of. So when you're running an experiment, you try to think of what is the control parameter, what is the manipulated parameter, okay, how or what is needed to cause it to happen. So that is the thing that you have to ask yourself. And one thing for sure, when you did your experiment, I think ada few student yang buat experiment, they dip, I think they dip it inside soap. So of course, the mechanism is a little bit different. Okay, so you do not have any some sort like maybe low electrical conductivity and so on. So that is the reason why you will not see as the things will not be badly corroded as what you have when you dip it inside acidic solution, when you dip it inside salt solution. And one more thing you can think of is that kenapa bila you fikir balik, kenapa kapal-kapal dekat tepi laut ataupun in the industry, you see a large industry. If you have ever been into Petronas in Kerteh, you will see there is a lot of materials that is being built up using stainless steel. How we protect it? Okay, why it is going to be having higher tendency to be corroded? Because you're using high temperature, you are using highly acidic solution, highly acidic environment, and so on, high pressure. So it need to be protected lah. Okay, otherwise you need to increase the cost in preventing the corrosion and so on. That's why corrosion is very beautiful subject. Okay, so I think that's all for my part. So I passed this part on application of corrosion knowledge and how to slow down the process to Miss Dian. And I think I can see that we have your question over here. We will answer your question later. Okay, now pass to you, Dian. Good luck.
Hi, everyone. Let me just share the screen first. Great. I cannot. All right. Okay. So for my part, there is not much. We are just going to see through on where can you find the corrosion and why do you actually learn corrosion, because corrosion is a worldwide problem. We have it. We can see that the problem in our daily life. So we need to know, we need to understand how does corrosion happen, and so we can treat it. So this is part that I will share with you on the application of the corrosion knowledge, meaning to say that on how we can prevent the corrosion. It's not like 100% prevention, but we can slow down the process as you have learned on rate of reactions. So you can slow down any chemical reactions, including those reactions in corrosion. Okay, so let me just proceed with you. Okay, can you think of any example of corrosion process in daily life that you can encounter? Okay, that you may have encountered those things that is around your house, around your like in your maktab, if you are there. I don't think so. Okay, so all right, so the example that you can see are like, okay, for example, in old cars, okay, some cars that has already the pins that are already scratched out, okay, so it will tend to corrode, okay. And then you can also see if you live by the sea, okay, so you can see the ships are tend to highly corroded, okay. So there is a reason behind this, and this is very close to what Madam Izni has shared to you. Okay, so what Madam Izni has shared to you is that under the presence of electrolyte, the ship is going to, the metal is going to corrode faster. So basically, this is a concept in which you can see that ship will corrode faster because there is seawater that contains a salt. Okay, so it contains salt, so it will act as an electrolyte. Okay, and then next up is you can see also if the jewelry is not made up of gold. Okay, you can see that the jewelry can corrode. Okay, so it can corrode and it can rust, of course. Okay, wait. All right. Next up is you can see in your any pipeline that you may see that this is always available. I do not know what about MRSM Taiping, but I think MRSM Taiping is older. Old maktab as well, right? So when I was actually an Ansara from Kuantan, okay, I took my SPM in 2012. Okay, so these kind of pipes are very abundantly available in my MRSM back then. Okay, and then we can have any utensils. Okay, you can see that the spoon or any knife, okay, if it is being exposed to the air, okay, some of it, okay, so they will tend to become corroded or rust. Okay, so the question is, can we actually avoid this corrosion? We cannot avoid it at all, okay, but we can reduce it. Okay, we can slow down the process. Okay, I'm sure that you have learned on how, what are the methods on slowing down the process and so on. Okay, so the first one is you can slow down the process by doing the barrier coatings. Okay, meaning to say that you are putting a layer that separates your like your metal, okay, from the air or from the water, okay, that can cause corrosion. Because if remember, if a corrosion need to happen, okay, you need to have the metal that is in contact with your air, okay, which contains oxygen, and also it must be in contact with any moisture that can act as the electrolyte. So if we have the barrier coatings, okay, then we can avoid the metal to be in contact, okay, with oxygen or water. Okay, and then we can have galvanization. Actually, galvanization is an example of barrier coating as well. Okay, but just the mechanism is a bit different. We will see later. Okay, and we can also do alloying. Alloying is a process that you make alloy. Okay, so this is a part of material science. Okay, so if you're interested to do a material scientist and everything, so this is one of it lah. On alloying, you should understand this. Okay. And then we can have cathodic protection, or sometimes it is called as sacrificial protection. Okay, so all of basically that I can see, these are the four means way that we can prevent the corrosion. So let us see where can we find this in your daily life. So maybe after this, when you go out, okay, and you see some of the like your car, okay, your gates, okay, at your house, okay, so you can see that, oh, there's a lot of application of this corrosion inhibition. We want to reduce the corrosion, or you want to reduce the rusting. Okay, so there are ways to do that. Okay, so let us go with this. Okay, so this is an example of okay, this is an example of barrier coatings. Okay, this is one of the method to prevent the corrosion, actually to slow down the process. Okay, so you can see why we do coating. I think I have mentioned to you just now. We want to prevent our metal, okay, from being exposed to the oxygen or the moisture, or both. Okay, so what are the methods that you can use? Okay, you can use paint. Okay, you can use oil. You can use plastic like polymer. Okay, and you can have actually this is quite a method. Okay, we call as the powder coatings, and also we have electroplating. Okay, all right. So I'm sure that you have learned about the electroplating process. So I don't think that this is something very new to you. Okay, so let us see. On first, you can see this one. I am sure, like as a Malaysian, okay, kita semua dah pernah tengok this kind of pagar, okay, panggil pagar hijau. So actually, this pagar, okay, they are made up of They are made up of metal lah. Okay, but the metal is actually being coated with a PVC. PVC, what is PVC? It is polyvinyl chloride. Actually, it is a type of polymer. Okay, so polymer plastic here. Okay, so you can coat it. So what happened is that when we coat it, okay, so our fans, okay, dia takkan it will not be like in touch dengan oxygen ataupun moisture sebab dia dah protected. Okay, so same goes with paint. Okay, sekarang kita dah ada paint atau cat yang very apa orang kata, it's very advanced. Okay, we have a lot of types of paint. Okay, that is very good for certain condition. Okay, if you are having a conditions that is macam kalau tempat tu if you want to use it untuk tempat yang selalu hujan, okay, you need to use this type of paint and so on. And basically, if you want to avoid corrosion, okay, avoid rusting or corrosion from happening, you can actually paint the metal. Okay, but it really depends on the applications. Like some products, it cannot be painted because of some reasons, okay, like safety reasons or so on. And then you can have this lubricant coating. Okay, actually this kind of lubricant coating, you can just go to Mr. DIY or anything. You can find something like anti-rust spray or lubricants. So these are things that commonly for lubricants or grease, you can see here. Okay, so for the lubricants or grease, actually this is more commonly used when you are using a part that is moving, macam dekat pintu, what do we call that? Engsel pintu tu. So we are
door hinges.
Yeah, door hinges. Okay, yeah. So commonly we will put in some grease, okay, to increase the movement, and you want to avoid it from become eroded. Eroded is because of its movement. Okay, so you don't want it to be exposed more to the oxygen and moisture and speed up the corrosion process. Okay, so same like grease coatings. Grease coating is widely used in industry. Okay, so it's widely used in industry because especially for parts that is in machines or anything, we will use this, especially for the moving parts. Okay, so and then we can have powder coatings. If you are interested, you can read through about the powder coating. This is quite a I think it's quite a new method lah. All right. Okay, so that is the keys for the barrier coatings. Okay, and then I will, before I proceed with the alloying, I want to talk about this galvanizing. Okay, so galvanizing is something that you may have encountered it, but this kind of material that undergo the process of galvanization, but you may not know it for like you do not know what actually happens. Okay, so what is the galvanization process sebenarnya? Okay, galvanization process ni kita guna untuk stainless steel. Okay, or steel, basically steel ni kita dah alloy, kita dah dah reduce dah dia punya process from being from being rusted or anything. Okay, tapi it's still possible for it to rust, so we want to further inhibit it. Okay, so commonly ni dalam proses in industry. Okay, so we will clean up, basically this is just clean up the steel. Okay, and then we will put in the zinc bath. Okay, so this is what we call as a molten zinc bath. Okay, so molten is going to be very hot. Sometimes it is being called as a hot, what do we call it? We call it as the hot deep galvanization. Okay, so then you will produce this galvanized metal. So what is it is made up of? Actually, steel tu macam agar ke apa kan, so kita akan coat with the zinc. Okay, so zinc ni dia macam satu protective layer lah, tapi sebenarnya what happen is that why galvanizing process is a bit different is that satu, of course it will avoid your steel from being in touch with the oxygen and water, but it is more selectively corroded. It will tend to corrode. Okay, because you see like for example steel composed of ferrum. Okay, mostly ferrum. Okay, and then there are some other metals. Okay, and if you compare with the zinc, okay, zinc is more reactive. Okay, this one is on the electrochemical series that you have learned. Okay, so zinc is more reactive, so when they are in touch, actually we need to select which one will tend to corrode. Okay, so in this case zinc akan corrode dulu. Okay, so basically zinc will produce a white rust. Okay, and this method has been proven that it depends on how thick your zinc coating is. Okay, so it can last around 70 years at least. Okay, so that is at least. Okay, so maybe you have heard of maybe you have seen this kind of white rust or anything. Okay, so this is a kind of what do we call it as the coating that we do with the galvanization. Okay, so macam like tepi highway, something you can see this easily. Okay, so dia ada some kind of like debu yang macam warna putih. So actually that is that may be caused by the white rust, especially when the surface is a metal. Okay, so if kalau awak cuba tengok ni, so awak akan nampak that there is white rust ni, and dekat bawah ni tapi still ada rusting. Okay, so kenapa? Sebabnya zinc ni dia akan corrode dulu. So dia akan corrode, lama-lama dia akan exposekan steel. Okay, so bila ada steel, so steel tu still exposed, dia akan lama-lama kan sebab zinc tu dah tak ada. Okay, so dia dah corrode jadi white rust and everything. So lama-lama steel kat bawah tu akan mula react dengan oxygen, okay, dengan water. So dia akan karat juga. Tapi itu kita cakap kita nak just slow down the process. Okay, so this process may take years lah untuk jadi macam ni. Okay, so it is one of the method, okay, untuk kita slow down the process. Alright, okay, then I'll proceed with this alloying. We go back for a while. Okay, I'm not sure the word that I use is correct or not. Copper is tembaga and brass is wasa. Okay, so I hope that it is correct. Okay, so actually previously our ancestors may have used copper as a plate or anything, right? So tapi copper ni dia boleh, it still can undergo some corrosion, but it's not like as reactive as the iron. Okay, but actually we can make something like not a corrosion proof, like it's like a better material, a better metal by doing this alloying. So actually ada juga example lain macam iron gate. Okay, so gate ke apa kan, kalau if it is made up of iron, as time pass, okay, dia akan berkarat and it will become apa ni, dia akan reput. Okay, so as a way to avoid this, kita akan make a stainless steel. Okay, so the stainless steel is that we are mixing the iron with other metals or other non-metals like carbon, nickel, okay, chromium and so on. Okay, so kalau tengok pun stainless steel ni dia ada different grade sebab dia different composition dalam tu. Okay, so actually alloying is a very cool invention, okay, I think among in human among human lah, sebab we can produce something that is more that has better performance and so on. Okay, then per se, I think this is cathodic protection, or maybe you have learned about the sacrificial protection. And this cathodic protection, we sacrifice the other component to become an anode. Okay, so this one goes back to your concept of the galvanic cell or the voltaic cell that you have learned. Okay, so commonly this cathodic protection, it will be used in pipelines, okay, in construction, okay, and also in marine, like a ship. Okay, so because I just mentioned to you, ships they tend to corrode easily, so if you can have this kind of cathodic protection, so this can reduce the corrosion. Okay, so I think that is quite a time. Let us just do some activities. Okay, you try, okay, you take out your phone and go to this file, sorry, this link. Okay, sorry, I don't have the. All right, so can all of you go to this link? Just, I think use your phone, it's easier. Okay, you need to put in your name. Okay, because Mother Izni said if we want to pick up winners. Okay, so if you can answer it correctly and as fast as you can, so we want to pick up the winner. Okay, I'll give a bit more time for you to go to the link. Okay, so maybe I'll put the link here in your in the chat box. I have put it as well. Okay, so why stuck? All right, okay. So, okay, the rule in answering this, I hope that all of you can access this, right? Okay, So the rule in answering this is that you need to make sure that you get a correct answer, you will get marks. And if you answer it faster, okay, you will get more marks. Okay, so that is how we are going to pick up the winners. Okay, so for this one, and you are only being given around 15 seconds to answer. Okay, so you need to look quickly, okay, and answer this. There is only around 10 questions.
Okay, Dian. Kita try to engage with the students since we are having one-way communication. Are you guys there?
Yes. Yes.
Okay, good to hear your voice because normally we don't really like one-way communication. You should interrupt. You should talk to your teacher. So we are your teacher today. Okay, now please participate in this one. So you just go to pollf.com. So under Miss Dian punya link. So answer this question, okay? So we just want to see whether you understand the way how we deliver the content or not. Okay, all the best.
Okay, do you guys have any problem in going to the link? I hope no. If you have any problem, you can raise your hand. Okay. So seems like no problem. All right, so let us go with the first question. Okay, so stuck a bit. Okay, so the first question is what I think this is available in your Voltaic Cell that Madam Izni just mentioned to you guys. Okay, so what is the instrument we use to measure the voltage, okay, that is produced from the electrochemical reaction in a Voltaic cell? Okay, I don't know which one you guys use, Voltaic cell or galvanic cell, but they are basically the same thing. All right, okay, so you have around 10 seconds to answer this question. Jawab. All right, so we have around 35 students, 47, 40, 50. Okay, 54. Okay, I think, yep, the 15-second time is up. So let us see. All right. Okay, so 81% mentioned that the instrument is voltmeter. Yeah, no, galvanic cell and voltaic cell, I just mentioned, they are the same thing. Why do you want to use ruler? Okay, we did use ruler to measure the electrochemical reaction, the voltage produced. So as its name, we want to measure the voltage. So of course we use the voltmeter. Okay, so let us see the leaderboard as of now. Okay, so I think quite a lot get it correct. Okay, so we can see Ami, okay, Ami, Aina. Okay, so we have a lot more questions to do. Okay, so let us proceed with the second question. Okay, so the second question says oxidation process involve. Okay, okay, now, where is it? Kind of stuck here. Let me just go back. Right. I need to use my iPad, I think. Doesn't appear to be right. Oh, yeah, yeah.
Okay, Dian.
Wait, I think that is because of my internet maybe. So I need to use this. Okay, yeah, it's back.
Back.
Okay, so 15 answer. You have 5 more seconds for
9, 40. Oh, laju. Good.
Okay. All right. Okay, time's up. Okay, the poll is logged. All right. So let us see if you get it correct. This is a very, very basic concept. Okay, let us see. Next up is Okay, right, good. Okay, so 88% mentioned loss of electrons. Very good. Okay, don't be confused. Okay, you can use any acronym or anything. Okay, Madam Isni, do you have anything to add? Because you just mentioned to them.
About oxidation process involved. So you remember that LEO and GR, so that will give you the idea on the correct position of the electron. Actually, the trick is very simple. You just want to look at the way how you balance the charge. Okay, so that will be the position of your electron. So automatically oxidation is where you are going to lose your electron. So it's basically the electron should be positioned in your product side. Okay, yeah. The ranking.
Next up, we have the leaderboard. Okay, seems like
Still, Amin lagi.
still leading.
Okay.
Right? Okay, so we can have still some more. Okay, let us proceed with the next question.
Why there's
Okay.
no more name?
Sorry. All right. Now, okay, in a galvanic cell, the anode. Okay.
Negative terminal.
Right. So in a galvanic cell, the anode is going to be where the reduction occurs. Is a negative terminal.
Rabiato, did you raise your hand? Any question there? Rabiato result. Okay, come on guys. 52 results. Okay.
So let us see. Right. So, yep.
69%.
Wow.
Okay.
Anything to add here, Isni? Why? We
Okay,
can have around 70-30 around that.
Okay, you remember in galvanic cell, so the anode is where you lose your electron. So when you lose your electron carry negative charge, right? So theoretically, your anode should be negative, your negative terminal, because that is the position where you lose your electron. And electron is going to be migrated from your anode side towards your cathode side. So that's why that explains your anode should be negative terminal in your galvanic cell. Okay, so ada 29% out of 50 plus students tadi jawab salah. Okay, remember your charge of your electrode is different when you compare between galvanic together with electrolytic cell. Okay, move, Dian.
Yep. Okay, so let us see the leaderboard. Okay, so there's still quite a students that got it correct and can answer it in quite a long time, a short time. Okay, so let us proceed with the next question. So in a galvanic cell, okay, galvanic cell again, yeah, voltaic cell, okay. So the electron is produced at, I think the answer is just mentioned by Isni just now. Okay, wait, seems stuck again. It's just because of the internet. Wait.
Okay. Baru bagi jawapan tadi.
Yeah, true.
Disappear again.
Yep, because it is my internet here. All right.
Okay, the electron.
All right, wait. Okay, wait. I think there is some issue here.
Internet connection. Okay, while waiting for Miss Dian to troubleshoot her PC, you have question there, Rabiatul? I think this is second time you raise your hand. Any question? You can turn on your microphone. Rabiatul, are you there? Any question? let me call random name maybe. Okay, you accidentally tapped the button. Okay, can I have Adibah Nawal? Are you there? Adibah? I just randomly pick up you and you are the lucky one. Not there. Akila Auni? Where is one more student who raised up your hand? No, it's okay. If you have any question, you can just turn on your microphone. You can speak up. Kena berani bercakap. So you know what? Just a little bit of sharing while waiting for Miss Dian to troubleshoot. Chemistry is a very beautiful subject. Sekarang ramai student tak suka chemistry, but truth to be told is that chemistry is very broad lah. So you are going to appreciate chemistry when you try to relate with application. You can see you're dealing with chemistry when you eat, even in your car when you drive. It's combustion reaction, it's chemistry. So when you cook, it's still you're using burner, whatever. So it's chemistry. How you process your food, how you can preserve the food. What else? How you take your shower, how you reduce your electricity bill, and so on. Everything is chemistry. How you use your steam iron, so why you have to use filtered water instead of tap water. The underlying reason is that you can try to figure it out. So what you can do is that while learning, try to explore and look at the application part. That is one of the way how you can appreciate the knowledge even more. So sebenarnya chemistry itu is not hard. It is that it's very beautiful. You can try to put a little bit of interest, effort. Bila you study on certain topic, what you can do, you can try to Google the application. Why is that happening? Why is that so? Why we have to put pain? Okay, and so on. Okay, it's back. Okay.
Yeah, I think cannot share through sharing screen. I need to share straight away from this. Okay. So it's already back. Okay. So let us proceed with this one. I think many have answers this. We actually have 53 response already. Okay. So I'll just wait a bit more until the time stop ticking. Okay, so we have around 60 response. Let us see what is the answer. Okay. Okay. Yeah, sorry, this is just previous question, right? Okay.
Okay.
All right. Let us proceed. Okay. So this is a question that we have just now. The electron is produced at, okay.
Laju, 50. We have 100 plus students, tapi only half of it responded. Okay, the electron is produced at anode. Okay, good.
All right, so, okay, good. So because oxidation occurs at the anode, right? So electron is produced there. So not cathode, okay, not voltmeter, obviously.
Nasib baik tak ada yang jawab salt bridge, tapi ada yang jawab voltmeter.
Right, okay. So let us see the leaderboard right now is still, okay, I think many still got a full mark, okay. Okay, let us proceed. Okay, here corrosion will occur under the presence, it's loss of presence of the following, okay, except, okay, except. Okay, you have 15 seconds to answer. 10 more seconds. Okay, 3, 2, 1. Okay, time's up. Okay, so we have around 50 response. Okay, so let us see. If you got it correct, okay, corrosion will occur. Of course, a corrosion need a metal because metal is the one that undergoes a corrosion. So yeah, it doesn't need a soil. Okay, so what is needed, remember, it is
Metal is the one that is going to be oxidized. So
Yeah.
that's how redox reaction happen. So that's why the answer metal should be included lah.
Okay, so yeah, the answer is solved. So let us see. Okay, we still have some students that got it all correct. Next up is, okay, here, rusting is an example of corrosion. What is the metal involved in rusting process? Okay, so let us see what is the metal involved in rusting process. Okay, you have 10 more seconds. 9, 8, 7, 6, 5, 4, 3, 2, 1. Okay, time's up. Okay, the poll is locked. Okay, so let us see what is the correct answer. I think you can see what is the difference between corrosion and rusting. Okay, so the difference between corrosion and rusting is that the rusting involves the it is actually the corrosion of the iron. It's very specific for the iron. Okay, yeah, okay, or the ferrum, Fe. Okay, so that is about rusting. All right. So okay, good. Many of you got it correct. Next question. Next up is okay. So this is a leaderboard. Okay, still a lot of you got full correct marks. Okay. Okay, so which of the metal will corrode faster? Remember, yeah, if you answer faster, you will get more marks. You will you will be at the top of the leaderboard. Okay, so which of the metal will corrode faster? Okay, this relies on the concept of this electrochemical series or the standard reduction potential that you have learned. Okay, so you need to think quickly. All right, so which one will corrode faster? Five more seconds. 3 more, 2, 1. Okay, time's up. All right, so the metal that will corrode fastest, the one that will corrode fastest is going to be the one that is at the top in the electrochemical series. Okay, so it will tend to undergo oxidation. Okay, all right, so the faster one. Okay, so yeah, the answer should be zinc. Okay, because zinc is placed in a higher position in the electrochemical series, or it has a more positive, a more negative standard reduction potential. Okay, so this one maybe you guys need to revise again. Okay, so because only 48% got it correct. Okay, so let us see who is at the top of the leaderboard. All right, okay, so we have around 4 students here that got it all correct, with me being the one that responds the fastest. Okay, so let us proceed with the next questions. Okay, so what is actually the product of rusting? This one, actually Madam Izni have just mentioned it to you. Okay, so the question, what is a product of rusting?
Ni jangan tulis salah Fe2O3 should be subscript
Oxygen too. All right, okay, so we have 49 response. So the product of rusting will be, yeah, Fe2O3. Okay, oxygen is not the product. Oxygen is going to be the reactant, and electron is actually not a product. It is just about the transfer of electrons. So nothing, electron is not being produced. It is just being transferred. Okay, so good. Okay, almost 80% of you got it correct. The product of rusting is actually ferrum oxide. Okay, the iron oxide. Okay, next. See, so still these 4 students are leading the leaderboard: Amir, Aina, Azraf, and Noreen. Okay, good. Now let us proceed. Next question. Okay, so this one is on corrosion protection. So which one that you think the one that make the most sense if you want to avoid the rusting of a car? Okay. Okay, 10 more seconds. All right. Okay, so we have 53 response. Okay, the time is up. Poll is locked. Let us see which one is the best method to avoid the rusting of car. Yeah, okay. Actually, if you paint the car, that is the best way, and it is going to be more aesthetically pleasant to see. And of course, you don't want to do electroplating of the car. Okay, that is going to be very costly. And also, if you do galvanization, okay, cover with the zinc layer, okay, that I mentioned, it is very not suitable for a car. Okay, so your car is going to have some white rust that is not going to be looking good. Okay, same like a plastic coating, like a polymer, it is not a suitable material to use to protect the car body. All right, okay, so let us see. Okay, still we have this. Okay, now it shortens to 3 students that are top in this leaderboard. Okay, so we have Ame, Aina, and Azraf. Okay, let us proceed with the next questions. Okay, what about if you want to avoid the rusting of metal spoon? What do you think is the best way to avoid the rusting of metal spoon? Okay. All right, 10 more seconds. Okay, you need to respond faster. Okay, all right, time is up. Okay, so the best way to avoid rusting of a metal spoon is going to be alloying. Okay, good. Okay, of course, you don't want to carry out the sacrificial or catalytic protection. Okay. Okay, next we can see the leading board. Okay, so we have a top students there, Azraf. Okay, let us proceed with the next questions. Okay, what about ships? Why ships in the sea?
Dian, maybe this is the last question.
Yeah. Okay, sure. Okay, so we can make it the last one. Okay, so why ships in the sea tends to corrode more easily than car? Okay, this thing I think I have mentioned to you. What is the reason? Five more seconds, and we are going to select the winner. All right. Okay. So good. Okay, so that is the correct answer. And yeah, I think we have the winner here, is me, that got it all correct. Okay, Azraf.
Okay, what you can do, Azraf, maybe top two lah, Azraf and Nurin. What you can do is that you can contact this one to claim your gift lah. A token, a small token from us.
Oh, Izni, minta pelajar ni contact saya juga.
Okay,
Nanti saya
contact
boleh
Cikgu
bagi
Aisyah
token
juga.
from school. Ha.
Okay, so this is Miss Dian's number. What you can do is that you can contact Miss Dian. Top 2 je, Cikgu.
Okay, can I see the result, the last result?
Kami bagi top 2. Top
Okay.
6
Actually, we have 4 students.
Dian, Cikgu minta results tadi.
Nanti saya screenshot hantarkan cikgu.
Okay,
Because,
okay.
I am sharing other screens right now.
Okay.
Alright. Okay. So I think yeah, congrats to all, and I don't want to take more of your time. Okay, so let us just proceed with the summary. The summary here, I just make a very simple video. Okay, that what we have learned today. All right. Okay, so let us have a look. How do I know if I am sharing the together with the sound or not? Oh, okay, here, share sound. Okay. Okay. All right. Okay. I think, sorry. Yeah, I think that is all from us. Okay, we exceeded the time of 1 hour actually. So from me, I think that is all. Thank you very much to all students, and thank you also to Cikgu Aisha and Cikgu Julia for inviting us for this talk. Okay, I hope that you gain some beneficial knowledge from this sharing. Okay, and hope that it will be useful for you.
Yeah, thank you so much. I hope that you find this session is valuable for you. So just in case you have any question, maybe you can pass the question to Cikgu Julia. Cikgu Julia can come back to us. Okay, tapi Miss Dian punya number I already share. So you can contact her lah should you have any question as well. Nanti I put my number as well. But for you to redeem the prize, you have to contact her. Ya, dia nanti boleh share slide. Maybe we can share through Cikgu Aisha or Cikgu Julia. Okay?
All right.
Yes, please.
Alright. Thank you so much. I think that's all from us. Ada moderator ke nak come back?
Ada. Sekejap Okay, Azri.
Hai, okay. Okay, thank you. Terima kasih. Terima kasih pihak kami ucapkan kepada kedua-dua dan Madam Nurul Izni, Kerry dan juga Miss Nurdian Muhammad Rizwan atas proposal yang sangat menarik tadi. Terima kasih sangat dan terima kasih kerana sudi meluangkan masa dan berkongsi dengan kami semua input-input yang begitu bermanfaat sebenarnya. Dan juga terima kasih lagi sekali lagi kami ucapkan kepada rakan-rakan strategi Ansara Taiping iaitu Jabatan Kimia Matematika Sains Smart Taiping serta TNF Energy Sdn Bhd. Dan jangan lupa ikuti kami di platform sosial media kami. Dan akhirnya, marilah kita tutup majlis kita pada kali ini dengan bahagian tasbih tawaran surah Al-As.
Kita ambil gambar sekejap boleh? Kita ambil gambar sekejap Azri. Okay, students boleh buka kamera. Okay, Azri kita jom ambil gambar. Okay.